In this video, we are going to take our Terraform and Azure environment to the next level. We'll improve our infrastructure design by introducing remote state in Azure Storage and by enforcing governance using Azure Policy. Let's first look at the goals for this video. On the left side, you can see the journey of our Terraform project. From a simple single file in part 1 to a more structured and scalable design using multiple files and modules. Step by step, we have been building not just infrastructure, but real-world architecture. In this video, we take another important step forward. We'll move the Terraform state file from our local machine to Azure Storage, so enabling remote state, a stronger collaboration, and more reliable deployments. At the same time, our Azure environment has also evolved. We started with a resource group, expanded into a virtual network, deployed a virtual machine, and since then, security using network security groups and Azure Bastion. And now it's time to bring governance into the picture. By introducing Azure Policy, we make the environment more secure, more controlled, and closer to an enterprise-grade cloud design. So let's continue this journey. And explore these improvements together step by step. Now let's understand Azure Policy with a simple real-world story. Imagine an engineer is trying to deploy a new virtual machine in Azure environment. Before the deployment even begins, Azure Policy steps in, like a smart security guard, and checks whether this request follows the organization's governance and security rules. For example, the engineer may try to create a virtual machine with a public IP address. Since this could expose the environment to the internet, Azure Policy immediately blocks the deployment. Azure Policy can also enforce other important controls, like restricting VM sizes, allowing deployments only in specific regions, or requiring disk encryption to protect sensitive data. If everything is compliant, the resource is deployed successfully. But if any rule is violated, Azure automatically stops the deployment. In this video, we focus on a practical scenario, protecting our Azure environment by applying a policy that prevents virtual machines from being deployed with public IP addresses. Let's explore how remote states works. Imagine two engineers working on the same cloud environment. Each of them keeps Terraform's state file on their own laptop. One engineer deploys a change, but at the same time, the other engineer also runs Terraform. Now Terraform gets confused, and the environment can become inconsistent or even break. And there is another risk. What if one laptop gets lost, crashes, or the state file is accidentally deleted? To avoid these situations, we move Terraform's memory, the state file, to Azure Storage. Now everyone uses the same centralized state. Suddenly, we lose the memory of our infrastructure. And when one engineer is making changes, Terraform automatically locks the state file, so others must wait until the deployment is finished. This makes teamwork safer, smoother, and much more reliable in real production environments. Alright, now let's take a look at the Terraform project structure for part 5. First, we'll apply Azure Policy using a dedicated Terraform module to protect our environment. If someone tries to deploy a virtual machine with a public IP, the policy will simply say, "Sorry, you're not allowed to do it." Next, we'll improve our Terraform setup by moving the state file from our laptop to Azure Storage for centralized and safer deployments. Finally, we'll test everything. We'll see the policy block the VM creation and confirm that Terraform state is now stored in Azure. And as always, you can find the full code in my GitHub repo. The link is in the description and comments. So let's jump into the implementation. Alright, before we move to the terminal, let's quickly understand how our Terraform code is designed in this part. In the previous videos, we already talked about how to create virtual machines and how to organize Terraform configuration using modules. So we don't need to explain those part again. In this section, I will focus on three main things: the background configuration, the Azure Policy module, and how we are going to run the deployments step by step. Let's start with the backend configuration. Here we have a Terraform block which is used to define Terraform level settings like providers and backend configuration. Inside the block, we define an Azure backend using backend Azure RM. So this tells Terraform that we want to store the state file in Azure instead of keeping it locally on our laptop. Next, we specify the resource group name. That is Terraform-state-rg. It shows the resource group where our storage account is located. Then we define the storage account name, which is Azure Storage account that will hold our Terraform state. After that, we specify container name. Inside the Azure Storage, this blob container acts like a folder where the state file will be stored. Finally, we define the key, which is actual name of the Terraform state file inside that container. So in simple terms, the whole bucket configuration tells Terraform exactly where its memory should live in Azure. And we already talked about Azure Storage, like a container that we use in this video, and you can find the video in our channel. Inside the module, we first retrieve information about our Azure subscription. Let's move to the Azure Policy module. Inside the module, we first retrieve information about our Azure subscription. Then we define a custom Azure policy that denies the creation of public IP resources. The core logic of the policy is defined in the policy rule. Here we check if the resource type being deployed is a public IP address, and if that condition is true, Azure applies the deny effect and blocks the deployment. We use JSON decode because Azure Policy rules must be provided in JSON format. Terraform allows us to write the logic in a clean structure and automatically converts it to valid JSON. And you can see our JSON decode. So after defining the policy, we assign it at the subscription level so that it becomes active across our environments. Now let's talk about how we are going to run this deployment. We will execute it in two phases. In phase 1, we will run Terraform to apply only the Azure policy while the virtual machine deployment is disabled. In phase 2, we will enable the VM deployment and run Terraform again. This time, Terraform will try to create a virtual machine with a public IP address. And since the policy is already active, Azure should block that deployment. Alright, now let's run the code. At this point, Terraform is configured to move the state from local storage on our laptop to Azure Storage. So when I run Terraform now, it will initialize the backend connect to the Azure Storage account, and migrate the existing state file to blob container we define in backend.tf. I'm gonna run Terraform init. Once that process, Terraform init. Once that process is complete, Terraform will stop using the local state file and start managing the environment state directly from Azure Storage. So after this migration, we can verify it in two ways. First, in VS Code, we should no longer rely on the local Terraform.tf state file as our active state. So I think we don't have any Terraform state here. And second, in Azure Portal, we can go to the Azure Storage, open the blob container, and confirm that Terraform.tf state file is stored there. So let's verify our Terraform state in Azure Portal. So if I go to storage account, and if I go to containers, so you can see our container is here, TF state that we used at our Terraform code. If I click on TF state, I can see the Terraform TF state, and so you can see we already created our Terraform TF state on Azure Portal instead of storing at our laptop or local machine. So at this phase, we are going to run our Terraform code and apply Azure Policy to our Azure environment. Terraform plan. So I'm gonna pause the video, and then after applying our Azure Policy, I'm gonna run the phase 2. So now you can see we are going to apply our policy on our Azure environment. I'm gonna confirm it. Yes. And then I'll show you the result. So our Azure Policy was applied. So I'm gonna run the phase 2 now. For phase 2, we need to change one parameter in our Terraform.tf vars. So we need to go here and change the deploy under VM to through. So, and then I'm gonna run our Terraform code again. It's gonna show us that we are going to create a virtual machine with public IP address. Oh, sorry, I do something. Okay. So it shows us that it's gonna create a virtual machine with a public IP address. So let's run it and I'll show you the results. I'm gonna confirm it, and then as you can see, Terraform failed with 4.3 forbidden error. This means Azure did not allow the resource to be created. And more specifically, the error says request disallowed policy, which tells us the deployment was blocked by Azure Policy. In this case, Terraform was trying to create a network interface for the virtual machine, but that network interface included a public IP configuration. Since our policy is designed to deny resources related to public IP exposure, Azure evaluated the request and stopped it before the deployment could continue. So this is exactly what we wanted to test. Terraform is working correctly, but Azure Policy is enforcing governance and preventing a non-compliant resource from being deployed. Alright, in this part we improved our Terraform design and made our Azure environment more secure and production ready. We enforced governance using Azure Policy, and we moved our Terraform state to Azure Storage for safer and centralized collaboration. In the next video, part 6, we will run Azure Backup and Terraform import and see how real engineers protect workloads and bring existing resources under infrastructure as code. Thanks for watching, and see you in the next video.